Proof Test Committee gradually merges, gathering members into a full-fledged unit, Joint Task Force 3, a unit operational by November 1949. This task force is an organization made up of 4 integrated parts, 4 task groups. Thus, Task Force 3 for Greenhouse reaches an objective not entirely realized in sandstone. This is a true quadrilateral unit in which each task group is assigned the job for which it is best suited. The aim is functional efficiency rather than service interest.
In essence, the mission of the Scientific Task Group is to prepare, arm, and fire the test weapons, to conduct the experimental programs for the Atomic Energy Commission and the Department of Defense, and to operate and maintain the necessary base and laboratory facilities for conducting experiments.
The Army Task Group will provide the necessary men and equipment to rehabilitate Eniwetok Island, and will continue to operate and maintain the island during the operational period. In addition, the Army will operate port facilities and ensure the physical security of the atoll.
The Navy Task Group is charged with the responsibility of maintaining surface security over the Eniwetok danger area. It will transport the experimental weapons and provide assembly facilities. The Navy will provide logistic support for the operation and augment facilities for intra-atoll water transportation.
The Air Force Task Group will provide and operate aircraft necessary for the experimental programs and the airbase facilities necessary to maintain these aircraft. It will assist the Scientific Task Group in collecting test data. Also, it will maintain a continuous display on the air situation, operate search and rescue activity, and provide documentary film coverage.
4 task groups, representing civilian and military personnel, now work together as a unified team, as a task force. Eniwetok Atoll, the proving ground, established as a permanent site for firing atomic weapons. Since this atoll had been used in the 1948 tests, there were some buildings, living facilities, and test installations available. But 2 years have passed. Repair is needed. Expansion is necessary. Cleanup, construction, and maintenance on all islands of the atoll, except Eniwetok Island, is handled by the civilian engineering firm of Holmes and Narver in Los Angeles. The first step of their engineers is to get a clear picture of the requirements, to make a survey. And while in the far Pacific the isolated proving ground is being prepared, in other parts of the world, events occur which give added significance to and have a profound effect on the planning for Operation Greenhouse. A hydrogen bomb, a fusion bomb, a thermonuclear weapon, call it what you will, the moment for decision arrives. The world situation offers no other choice but to push the development of this type atomic weapon.
A thermonuclear reaction. We know the reactions on the sun are of this kind, probably the slow fusion of hydrogen taking place over millions of years. Our problem is also to produce a fusion reaction, but that is as far as the similarity with the sun goes. We can't wait a million years. Ours must be here and now and explosive. A tall order, but because of the urgent need to know if a man-made thermonuclear reaction is possible, we are going to burn the midnight oil until we have an answer. By now, we know the blueprint for mass and energy. We know how to cause the splitting or fission of heavy atoms to produce an explosive chain reaction in the case of uranium and plutonium. When fission occurs, the total mass of the 2 fragments is less than that of the original mass. That difference is energy. Fusion, as the term implies, is a fusing together of 2 atoms into a single nuclear unit, the direct opposite of fission. But still, for light atoms, the new mass is less than the combined masses of the original atoms. The difference, again, is energy. However, energy from fusion weapons, theoretically at least, is unlimited. Unlike the critical mass limitations of uranium and plutonium, any given amount of active fusible material can be assembled to produce an explosive force. All this is true if a suitable material is available. Ordinary hydrogen, the common element used so frequently and inexpensively, fuses and produces energy on the sun. But on Earth, ordinary hydrogen atoms do not easily fuse. Simple hydrogen is definitely not suitable as a thermonuclear fuel, but it is believed rare forms of hydrogen will work. So, one of our first problems is to experiment with an isotope or isotopes of hydrogen. Work with materials capable of undergoing an ignitable, self-sustaining nuclear reaction. If we can prove that it is possible to achieve a self-sustaining nuclear fusion reaction in a small quantity of material, we will have a starting point. We're going to try to be ready to attempt the test of a measurable thermonuclear reaction in a little over a year on Operation Greenhouse.
Not only is work intensified at Los Alamos and many other labs and installations in the United States, but also in Eniwetok Atoll, engineering work is rushed to make possible the test by the spring of 1951. Construction starts from the ground up and grows into a proving ground. While work progresses in the Pacific, preparations keep pace in the ZI. Preparations based on 8 experimental programs.
Program 1, Los Alamos Tests. Designed to obtain answers to several key questions relating to the national stockpile of fission weapons, to effects which nuclear weapons are capable of producing, and to possibilities in the direction of thermonuclear weapons.
Program 2, Biomedical, sponsored by the Atomic Energy Commission and the Department of Defense. It will consist of the measurement and recording of the effects of the atomic explosion on animal and plant tissues.
Program 3, sponsored by the 3 services. The response of various types of buildings to the atomic explosion will be measured and analyzed and will provide a test of various types of blast-resistant construction.
Program 4, Cloud Physics, sponsored by the Air Force, will consist of the measurement of physical phenomenon accompanying the cloud which is formed after the atomic explosion.
Program 5, Radiological Instrument Evaluation, is sponsored by the Army and Navy. Its object is to evaluate equipment which has been designed by the services for use in detecting the radiation produced in an atomic explosion.
Program 6, Physical Tests and Measurements, will consist of 10 separate projects to determine the effects of atomic explosions on various kinds of military equipment and the effectiveness of decontamination methods.
Program 7,